Hey everybody, welcome. My name is Caleb, and this is your introduction to SQLite. This is a fabulous tool, database that I think every developer should get some experience with. So we'll start by talking about some of the reasons you might want to use SQLite, and then we'll talk about some of the basic commands. Before we get started, I wanted to mention that you can get a free Intro to the Software Development Career course. This is an introduction for a larger course that goes over everything you need to know for software development, including a specialization in front-end, back-end, or DevOps. This is with a platform called Course Careers, and I am one of the instructors for that course, but you can get the intro courses for free. So I encourage you to check that out. I'll leave a link below. And then additionally, you can get many of my videos ad-free and downloadable on my website, so I'll leave a link down for that below as well. Oh, also, I'm taking the code from this video if you want. I'm putting it up on GitHub, so if you need to copy that or use it for your own examples, that's where you can find it. I'll also leave a link to that as well. So first off, how do you pronounce SQLite? Here is a post from the author of SQLite saying SQLite. So I guess SQLite, kind of close enough, but he does say, hey, I don't really care. Do it whatever you want. You can find the SQLite webpage at sqlite.org. Website looks a little bland, but that's okay because the database itself is actually pretty awesome. It's actually probably one of the most popular databases because this is often called an embedded database. It's embedded with software that is then distributed. So the total number of instances out there of SQLite is probably a ton. Available on all mobile phones and most computers, and bundled inside countless other applications that people use every day. The magic with SQLite is that it does not create a separate process for the database. It's embedded in whatever application you're creating. And this is what is meant when they say that it is serverless. So you can see this page here. And it is an example of a classic serverless software where the database engine runs within the same process thread and address space as the application. There is no message passing or network activity. Let's compare SQLite to what you might experience in a typical web development database setup. You'll have a separate database server, and everybody who views this web page is all going to share that same database through some kind of backend that accesses that database. So you'll pretty much have one database for the entire application. That is often not the use case for SQLite. Instead, you can think of if you have desktop software or software that's going to be distributed through IoT, or you can think like appliances, or basically anything where there's going to be many instances of that database, and these are not connected or centralized in any way, that is likely where SQLite is going to shine. So if you need to pair a database with some software that you're going to be distributing instead of hosting yourself as a software as a service, then you might want to look into SQLite. Now, that doesn't mean you can't use it for web development. It's actually pretty effective, but as my first choice, I probably wouldn't use SQLite. Here are some more examples of where SQLite might work well, and you can see for websites it does work, having the ability to support hundreds of thousands of visits. But if I was just planning a website from the beginning, I'd probably just go with something like Postgres or another relational database. One other major benefit of SQLite, though, is that it's free to use in production, commercial use, so that means you don't have to worry about paying money if you don't want to, which I'm not sure any of us are going to want to pay money, but there are different licenses here if you want legal proof of their right to use SQLite. So you can read more about that if you wish. But in general, SQLite is easy to work with, free to use, and works great for many uses. So we're now going to get started by downloading SQLite and getting some experience with some of the commands. So you can go to the download page here, and you can read through this. I'm actually just going to use Homebrew as I'm on a Mac. So from the terminal, I will say brew install SQLite. And if you don't have Homebrew, you can install that very easily. And you can visit brew.sh and paste this command in your terminal to install Homebrew. This is a Mac operating system software or Linux. So if you're not on Mac, then you'll want to go to the SQLite download page and go through one of these different options. Now we're going to use SQLite from the terminal, but in an upcoming lesson, we're going to talk about how to use SQLite from an application. So say you have a Node.js application and you want to interact with the database. We'll talk about that in an upcoming lesson. For now, we're just going to work directly with SQLite from the terminal, or you could probably create SQL files as well. Now when this is done, it will give you back a command that you can run to add this to your path. So you can use the SQLite command from the terminal. So I'm going to copy and paste that and run. Now you should be able to say SQLite 3 and then create a file. So we'll just say intro.db. And this will launch SQLite and create an intro.db file. Now the first command I wanted to teach you is .shell clear, and this will clear the screen. So anytime you need to do some terminal command, you can use .shell, and you can use the up and down arrows to go to previous commands. So that was an example of a dot command, and there are various others. So here are some of the other ones you might want to know about. You can find this in the docs, or I guess sqlite.org/cli.html. And scrolling through here, you will find special commands to SQLite 3. And these are dot commands you can issue to get information about your database or do things that are not SQL. So SQL, structured query language, that is the language for actually interacting with the database. But sometimes we need to do stuff surrounding that, which isn't SQL, and that's going to be a dot command. So for example, you could say .help, and this will give you a list of these commands. Another one would be .tables. Not going to list anything now. .show to get current settings. .databases, and you can see the path to this database. .schema. Again, not going to show anything. We haven't actually created anything yet. And there are various other commands. So as you go through this, you can use those commands to get more information. So let's now talk about creating a table. A table is going to describe some entity. So you'll say create table. Typically this is in all caps, but the actual names you type are going to be in lowercase. So for example, if you want to store user information, you might say users, lowercase. And then inside of parentheses, you'll open the parentheses and then hit enter. Then you'll put everything you need inside of the parentheses, and then at the end, you'll close the parentheses. It's a little bit more complicated working in the terminal, but we're going to start with this here. So you'll always have a primary key, and we'll call that ID. It's going to be of type integer, and then you'll say primary key. Now after each column, you will put a comma, hit enter, and then you can move on to the next column. So for example, if we want to store the person's name, that will be of type text, and then we could say not null to say that it's required. Next up, we could have a username. This would also be text, not null. And we could make this one unique. This is a constraint, meaning some other user can't use the same username as you. And then we'll say email. This will be of type text. Now you could use not null, meaning it's required, or you could say unique, but just showing some options here, we'll just leave it as just text. And then age, this will be of type integer. And then we could create a created at, which will be a timestamp. So you'll say date time, default is going to be the current timestamp. So if you don't provide a value, it'll default to the exact moment in time that you create the user. Then on the last one, we don't need the comma, and then we'll close it with the parentheses and a semicolon to finish the statement. And then it goes back to the SQLite prompt. So we created that user table, and now we could say .tables, and you'll see that we have that user's table. Now you can also say .schema, and it'll show you the create table for all of our tables. Now it doesn't take very long to realize that working inside of the terminal can be a little bit of a pain. If you mess something up, it's hard to go back, and you have to do things one line at a time. I generally prefer to work in a file and then execute that file. So I'll show you how to set that up now. So I'm going to use the Visual Studio Code editor, which you can use whatever editor you wish. But from here, I'm going to say file, new text file, and I'll save this in the same path as our DB file. And I'm just going to call this intro.sql. And then we can put whatever we want in here. So for example, select everything from users. And then we can run this just from a terminal inside of Visual Studio Code. You could also do it from here. And to do that, you would just say .read intro.sql. But I closed out of this session by hitting Control-C twice so that I could open a new terminal here. And now we'll say SQLite 3, and then it was called intro.db. So we have our session running. And then we can say .read intro.sql. Now we don't get anything back because we don't actually have any data in that table, but that's how you're going to do this setup. So let's get what we have so far by saying .schema, and I'm going to copy and paste this create table so that we have that up here. And then I'm going to tab this all over. And then what we can do is we can just comment it out using double dashes on each line, so we don't actually try to create that table again. But we at least now have a record of the SQL we've been using, and we can continue to build on this file, just adding new lines. So let's now talk about alter. Alter is a command that is used to alter the structure of tables that have been defined. So you could say alter table users, and then something such as add column, status, and we will give this the type text. Let's run this. And now when we take a look at our schema, you should see one right here called status. So that's how to create tables and alter them. Now let's talk about how to delete them. So to delete, you actually don't use delete, but drop. So it'll look like this: drop table users. We'll run, and we should now not have any tables. So if we say dot tables, we get nothing, and dot schema should also give us nothing. So those are the three main DDL commands I wanted to share: data definition language, which is to create a table, alter a table, and drop a table. This is why it's handy to have the SQL saved, so if you need to go back and create a table again, you can do that very easily. So we'll run that, and now we are back to where we started, creating the users table. So that's the basics of building structure. There's a lot more you could do, but we're going to talk about data manipulation language now, DML, which is used to insert data, update that data that's been inserted, remove data, and everything like that. So let's start by inserting some data into our table. So we'll go down here and create a new statement. We'll say insert into users, and then inside of parentheses, you'll often give the columns you want to insert into. Now, what needs to go in here? Anything that is required. So take a look at the table structure. The ID is going to automatically work for us, so you don't have to worry about the ID. The name is required because it's not null, so is the username. And I think that's it, because the email is not required, the age is not required, and the created at is not required, but it has a default anyway, so it'll create a value for us. Now, if you want to give those values, you can, but they're not required. So the bare minimum in here would be any columns that are labeled not null. So name and username. So let's try it. We'll say name, comma, username, and then you'll say values, and you can put this on the same line or the next line. And then inside of parentheses, we will give a name, Caleb Curry, comma, and then a username such as calcur123, and then we'll end with a semicolon. So now let's execute read. Nothing appeared to happen, which is usually good. So now what we could do is comment this out so we don't insert again, and then we'll say select everything from users. So this is how to read data. So we say .read intro.sql, and you can see that data. So the ID is 1, the name is Caleb Curry, the username is calcur123, then we're missing some data here, and then we have the created at timestamp. Let's go through another example creating some more data. I'm going to copy that, and then I'm going to paste it down here, changing it slightly. First I will uncomment, and then I'll just use a comma to add in additional values here. And we're going to change this first one as well. So we'll say John Smith, JS is his name, username. And then we'll say Sal Smith, and her username will just be SS. And let's go with one more. We'll say Cole Connor, and his username is going to be Cole C. Okay, I'll read, and that should be good. So now when we select the data again, which I should just keep this at the bottom probably, we'll put that down here and uncomment, and then I'll comment out these two lines. Let's select the data now, and you can see we get 4 values back now. So this is the data returned, and you can see each of their names, their usernames, and then when they were created. Now you can modify the select to do various different things. So for example, you could say where username is equal to JS, and then you'll want to move the semicolon down here. And now when we run this, we just get a single value back. So there are various things you can do with the select. So you can order the data, you can limit to just a single value. So for example, you could say limit 1, or you could say limit 2, and now we're just going to get 2 values back. So an example might be ordering it by the most recent created and then limiting that to just 5 to get the 5 most recent accounts. Now let's do an update. So this is going to change data. So we'll say update users set, and then you'll give the property or the column you want to update, such as email, and then we'll say new email at gmail.com. Now you can put more columns here if you want, but we'll just leave it at that. It's really important here to have a where, so you can specify which rows you want updated. Otherwise, it's going to update everything, which is not what you want. So we could say where ID is 1. Now, it's not white space sensitive, but I'm just trying to be consistent here. And then afterwards, we will select again so we can see all of the data. So it'll run, and now this is all of the data, and you can see Caleb Curry now has an email. Deleting data is also very similar to updating data. You'll just use delete and you'll remove the set section. So it might look something like this. Let's comment this out and we'll say delete users where, and then some condition. We'll just say ID is 2. We'll read that, and now our new data, looks like we have a syntax error, and that is we just need to have the from keyword. Sorry about that. So we'll read this, and now we only have 3 values in our database. Now let's talk about foreign keys. This is how you can make a relationship across 2 tables and is a key component of databases that are relational. I have a whole series on database design. You can check it out. I have a video on my channel as well as a video up on Free Code Camp that you can check out if you wish. That'll give you all of what you need to know with database design. But we're going to keep it really simple. We're going to create a table for posts. This could be for a forum where you create posts on a website, and each post needs to be posted by a user. So that will relate back to the users table. So we'll start by creating a new table. We'll call it posts. And notice how much easier this is to do inside of a text file. We'll say ID, that'll be an integer, and this will be the primary key, comma. Now we'll create the foreign key. To do this, you will give it a name. Now typically I'll just give it ID as well, but prefixed with whatever table you're referencing. This will be of the same type as that column being referenced, which is integer. Then you'll say references, and then the table that you're referencing, and then the column in parentheses. So this will create a foreign key. Then we could just have a title for the post, which could be of text, and then we could have a body. Oh, and we need to add in a comma right here, and that'll also be text. And for these, we will say not null, not null. We'll keep it pretty simple with just that. We'll save, and then read that. So that should have created a table, so we can say .schema, and you can see these 2 tables have been created. Now to create data inside of the posts table, we will first say select everything from users, and this will give us the different users and their IDs. We will need to take one of these IDs for whoever is going to create this post. So let's say Cole wants to create a post. It might look something like this, and I'll do this up in the SQL file, commenting this out. Insert into posts, and then in parentheses, the title, the body. Oh, we'll also need the user ID, so user ID, title body, and then values, and the first value will be the ID. That's not going to be in quotes, so we'll just say ID 4. Then the title is going to say my first post, and then the body could say something like more information about myself. Looks good so far. Let's try to run this. So we'll read, and this is just a mistake on my part. We should use single quotes for these values, as double quotes are often used for identifiers such as columns, so we'll just stick to using single quotes for our SQL statements. Now when we rate it, we don't have any issues. However, our select is not going to give us that user information by default, so if we say select everything from posts, we'll just see that user ID, and we'll want to make sure that we comment out these 2 lines real quick so we don't accidentally insert the data multiple times. And now when we read this, we'll get 1 post, and you'll see that the user ID is 4. And you can also say .headers on, and now when we run this, you'll see what those columns are. So ID, user ID, title, and body. So if you want to replace that ID with the actual user information, you'll need to use a join. So to do this, we're going to select pretty similarly, but it's going to be from 2 tables. So the easiest way to do this would be to just say select everything from posts, and then I'll go to a new line here and say join users on posts dot user ID being equal to the users dot ID. So we run this, and now we get all of the data across these 2 tables. Now this ID here is referring to the post, so we're looking at a post, and then this is the user ID, but if you scroll over, you'll get that user information. So for Cole Connor, and then their username and their created at date. Now you can specify what columns you actually want. So for example, you could say body and then username. We run this and we just get more information about myself from Kolek, which is his username. Sometimes you'll see this with aliases. So we would give an alias for posts. So we'll say from posts P, join users, and then we'll give that an alias U, and then we'll use that instead of the table name. So we'll just say p.userid and u.id. Then for these columns, we can do the same thing. So it's coming from the p.body and u.username. Now we run it, we get the same exact thing, but now we're prefixing each thing with where it's coming from, and it can save on some typing for the different joins. It's up to you if you want to do it that route. Now this can obviously be a little obnoxious and hard to remember, so a common approach is to create a view, which is a view into that data, almost as if it's another table. It's a virtual table, and it's going to be done like this. We'll say create view, and then we'll give it a name such as posts info as, and then we'll put all of this information, and I'll just tab it over. And then down here we can say select everything from posts info. So we'll run it, and we get that same information back, but now we're using our virtual table. You only have to do that once, so you can now comment this out and just treat posts info as if it's its own table. So if we insert new data, let's just go through a quick example where we will get the user ID 1. We'll say my better first post, purple is my favorite color. That's not actually true, guys. I'm lying. Sorry to lie, but all right, let's try this now. So I'll insert, and you can see we retrieve that new data through the view. So that is your introduction to SQLite. Obviously, there's so much more we could talk about and go in much more depth. I really just wanted to give you an overview of the different things you could do, so now you're much more prepared to learn about this on your own, as well as follow other videos such as an upcoming one I will create on using SQLite from an application. So if you want to learn how to code to this database, then definitely subscribe and check out my upcoming content. Appreciate it so much for you making it through this video. If you enjoyed it, please hit like, subscribe, turn on notifications. Let's just get 1 million subscribers, guys. That would be awesome. I would absolutely love that. So definitely appreciate any support you give me by subscribing and sharing this video with your friends. Thank you, and I'll see you in the next one.